Hello. All right. So welcome to the workshop to deploy the machine models on the Google Cloud Platform. My name is Dad. You can call me Eric. No. So I'm the tech coordinator at AIS. Okay. So if you have any questions, please try to comment, try to questions in the chat. All right. Okay. So I drop the link to the notebook. So the link to the notebook is where you can, so the notebook contains all of the code that you need to deploy the machine models on GCP. All right. So the agenda is that, so when you would, okay, so first of all, let's look at the roadmap, like how we go from like train the model, machine models on Google Cloud Platform, and then how we can export your model and deploy it on the Google Cloud Platform. So here I have also a brief graph of how you get your data, train it, and then deploy into the Google Cloud Platform here. So given you have a data, so here I have the MNIST data, which is the closed data here. So let's say your task is to classify the given image is a boot or a shoe or like a t-shirt. So so here I assume that you will using TensorFlow to write your code to train a model. And when I say that you train the models, I mean that you can either train your model locally, right on your local systems, or using Google Colab. Otherwise, you can perform the other training right on the AI platform, the GCP here. So, however, no matter which way you train the model, at the end, you have to export your model to Google Cloud Storage, because when you request the GCP to deploy your model, then the GCP will look at the Google Cloud S, which is the Google Cloud Storage. It will look at the GCS to look for your pre-trained models and deploy into like the REST API, so that let's say your app website can reach out and make the predictions. Okay, so first of all, let's go to GCP and create your machine and projects. I see. Okay. Give me a sec. How I can switch to, okay, no way. Okay, so, okay, let's say that, so here is the, the homepage of Google Cloud Platform. So from there, you can go to Cursor. If you haven't registered with Google GCP, please go ahead and register. So here I have already registered with GCP here. Okay, so GCP, when you sign up with GCP, it will give you $300 credits for the credits. So with that, given that credits, you can deploy your own model easily. So the next step is that, as I explained that, you need to create your machine projects, right? So go from there, you can go to, there's a box here, click the box and create a new project. Let's say I create a project for Hack AI. Okay, so after you create the, oh shoot. Okay, it's a process. Okay, so after you create your project, right, you need to copy the project ID, because here the project ID is it will be used to configure your environment. So are you good with registering with a GCP? Okay, right. Yeah, but did you finish registering the GCP here and create a machine project? I mean, just simply just a project on GCP. Okay. Okay. I assume that you finished with the creating project. That's fine. So right now, what you need to do is that you need to go to the notebook that I show you. I mean, I dropped the link into the chat. So in a notebook, it will give you all the almost all the guides that you need to deploy the machine models to the GCP. Okay. So first of all, let's clone this. Give me a second. Yep. Let's clone this repo. So within this repo, I give you like, I'll say sample code in order to configure your, I would say, online training on GSP. Later on in this notebook, I can show you like exactly what is within those repo. Okay. So first of all here, so as I said that you need to copy the ID project, right? And right here, you're gonna pass the ID project. Oops. The project ID here. Okay, so here we will use the G Cloud, which is the common package that will work with the Google Cloud Platform. So when you pass the project ID, then the G Cloud will configure and focus on that project specifically. And then next step is that you need to authenticate your access to the project. Oops. Okay, because here I already authenticate, but when you execute this block, right, it will ask, it will link you to another page where you need to, okay, well, where it will link you to a page or a site that will give you the code. So with that code, you can authenticate your access to GCP. So next step is that you need to create the cloud storage bucket. So the cloud storage bucket is like a hard drive where it will store your trend model. So the bucket name here, so bucket name is like simply the directory. So let's say it's hacker again, and the region here I will use US Central 1. Right. Now with this comment, I can create the bucket name HackAI. And then with this step, right, I will validate some access to the bucket. Okay, it all looks good right now. Let me see. Right. Okay, great. Okay, so here, here I just simply go over how to train the model. Like, on the Google Cloud platform. So as I said that we have the data set of calls, right? And let's say you try to like build a convolutional networks to classify the given image is it has the boot or a square or a shirt or not. So after your training, right, you need to export your model into you need to export your models. So that model will be a trained model that will be used that will be deployed into the Google Cloud platform. So I'll say that here, as I mentioned, that we can either train a model locally or using the Google Cloud platform to train it. So right here in this section, I give you some the instruction how to train your model using Google Cloud platform. Specifically, what you need to do is that, let's say here is your directory, right? What you need is that you need to set up Docker. So this file will it will package your entire code into, well, I say like a Python package. Basically, this is necessary because GCP will use that package to deploy your model. I'm sorry, it's to train your model. And under the project, right, you need a folder container and a task.py. So the task.py is where you execute all the codes to train your model. And these, and like a.py and p.py is like, they are just like, I would say, supporting Python files only. So in the task.py, right, let's say at the task.py, we execute the training pipeline. And at the end, you need to export the model into the format called safe models. So no matter, so here, you can train your model locally or using GCP to do the online training. But at the end, both methods must export your model into a format called safe models. Okay, so well, for using the AI platform, GCP AI platform and training model online, I'm not going to talk. There are some brief instruction later in this notebook, but right now I will go over like how to like train a model using locally on Google Cloud. So it's just briefly. So here I have a function called load data. Basically, it will load data. You load the image data. Load the image data, and then I have a function called input function. So input function, what it does is that it will process my data because my data is our images, right? And I want all of the image will be resized into the size of 224 by 224. So this and that is what my input function does. It will resize all my images into the size 224 by 224, and then it will zip the images and label together. So those so the input function we use to process images and load data. And finally here, I have a function called create model. So this model, if you are familiar with TensorFlow, this model will just simply build your model, build a convolutional networks with a single convolutional 2 layers and with a max pool and then a dense layers. So okay, so this is a very simple convolutional neural networks. I do this because I just want to like show you like how to like I would say deploy the models easily. So after you create this function, okay, okay, good. So after I finish with creating the create model, right here, I will write a function called train evaluate. This function will here, it will here, so it load data, process image here, and labels, and then it will build my model for me. And the next step is that here, I use the fit function. This fit function will train a model, right? So the fit here is a very common word in TensorFlow. Finally, after training model, right, after you need to export your models. So to export your model, you will use this function tf.keras.models.save model. So this one will I will take the train models here and save it in either locally or it will save the model on a Google Cloud storage. Okay. Oops. So here I just execute the training here to make it faster. So I will put the number of equals to 5 only. And here I put a chart directory to that pointer brackets because I want this function save model to save like the train model on a Google Cloud storage for easier, like for easy deployment. Right. Okay. While we're waiting for it get training, what we will do is, let me see. I think yeah, it's in GCP. Okay, GPU here. Huh, why so slow? Okay, so right now I just finished with training models on using Google Colab. If you want to train models using AI platform, you wait. I'm sorry. If you want to use a training model locally, let's say on Google Colab or right on your system, but using like you run all your codes into the script, right? You can use this function, G-Cloud, using this package G-Cloud to train the models. So this command here, it will specify that right now the training will be performed on a local Python, right? And then here, the G-Cloud AI platform local train, it will train the model locally. And so at the end, it will save the trained model directly to the Google Cloud storage. All right. So if you don't want to train your model using locally, you can train your model using AI platform to do online training. What you need to do is first of all, you need to create a chart directory, which is like where you want to store your model, right? And here is the chart name. The chart name is just like a name of that training process. Okay, I'm not gonna execute this because it will I will say it takes a lot of time because yeah, for a GCP to configure the training step. All right. So do you have any questions so far? Okay, if not, let's see. Okay, no. Interesting. Okay. So after we train them out, right? Now, so first, well, let's say usually when you deploy your convolution networks, right? Basically, the model will require a specific like requirements, such as like your convolutional networks model. It requires all of the input images at a size 224 by 224, right? Sometimes, however, sometimes in reality, the images that you receive from the customers or clients, they could be not in the size 224 by 224, so that you need to like resize it. In order to resize the images, basically what you can do is that you can perform some like custom prediction routines. I will go over the custom prediction routines later. The reason why I do is because I will talk about this the custom routines later because Google because if you deploy your models on QCP, right? That is easy. However, there are some cons such as that the custom routines running on GCP, they are in beta, so there's limited support for you. If you want like really want a custom production routines, I think you have to use in the Kubernetes where it's more complex. And I don't think it's like it fits for the hackathon. So, but here later I will go over the cluster prediction routines with some easy steps. Okay. Okay, so this one we will go over this later on. Okay, any question so far? Okay. No. All right. So okay, all right. So here okay, so here my model is trained, right? And it's saved into this directory. All right, so here the address doesn't look good. That's why I expected that, because well, this model is not designed for like the state of the art accuracy. It is designed for tutorial. So as I said that here, it says that now the model is saving to this one, right? Now let's go to my console and go to the stars. Where is it? Impossible. Should be here. That's weird. Let me see. First bucket is. I said the bucket is this. Ooh. But I said the AKI is this one, right? Okay. Oh, okay. I think I know why. Okay, that's interesting. Okay, the best way is that, okay, I restart my environment real quick. Let's see. Okay, let's do factory reset runtime. That's interesting. Okay, so here I need to authenticate some access to the new project. Well, just a couple minutes ago, because I run this notebook on another like projects, so probably that my environments remember the access to the past projects. So that's why I get this error 409. Okay, I authenticate my access to a new project. Okay, give a sec. Okay, we should be good now. Holy. Sure. Oh, okay. I think I know why. Probably because my last project has the same bucket. That's the reason why. Okay. It's not a big deal. Yep. Okay, what state? Okay. So after, okay, that's fine. Anyway, so when you well, when you create a bucket, right, it should create just the bucket for you successfully. But what I try to show you here is that so when you save the model into Google Cloud Storage, right, in the safe model format, what you have is that these three items: access, safe model, and variables. So these three items will be used to configure, I would say, for deployment later. Okay, give me a sec now. Okay, where we are. Okay, right here, where we deploy. Okay, now let's go to the deployment sections. So in Google, in the GCP AI platform, to deploy a model, what you need two things. First of all, you have to create the model resource. So model resource is just simply a containers. So if you heard of Docker, right? Docker, right? So here we say we create model resource. It doesn't mean that we just simply creating a Docker containers, where that each image is a version. So after you create a container, you need to create the model versions. So each version will be your own image, right? So when you deploy the machine models in the GCP AI platform, you need these two things: model resources and model version. All right. So here I name my model as CNN. So I will create my model here, resource. Okay. For the region, I will use a US Central one. So the name of the model, it can be anything. All right. So if you receive this message, create a AI platform model successfully, you should be good. And okay, let me see in the chat. Okay, no. Okay. Okay, so after you create the model resource, right? Now let's go to create the model version. Okay, now there's one thing you need to know is that so about the carrier export directories. Carrier export directories is simply just like it point to the latest trend models. For example, so here in GS, so here the common GS utility ls, and given the bucket PKI / CNN, right? So this command, it will list all of the trend models in the CN folder, which is these two, right? And then I will get the latest trend models. Okay. So now the safe model path, it will have the path to this latest trend model in the Google Cloud Storage. The next thing is that you need to name the model version. So here I would do I name it as version 1. Okay. So next is that we need to use the G-Cloud AI platform versions create to create a model version. For quick, so these two lines here I comment out because so these two lines for custom prediction routines. We will go over custom prediction routines later. So when we use the G-Cloud AI platform version create, right? When we use this command, we need to give it the model version, the name model. The name model here, I name it as CNN, exactly as right here. So given the version, given the model name, then we need to give it like which framework we want to use here, because I will use TensorFlow here for a safe mode because my army model right above I train a model using TensorFlow, so I want to use TensorFlow model framework here. and I will use the version 2.2 of TensorFlow. The latest one is now is 2.4, but but the difference between these two versions are not that big. And I will use the Python version of 3.7 here. Okay, now at the end, you need to give it the path to the latest trend models. Okay, and if executed, probably it's gonna prompt which region you want to deploy it. Okay, let me see. That's a weird. That's interesting. I should have to access that one. Okay, that is fine. Let me try to use this. Probably because of different comments. Okay, let me try again real quick. Wait, okay. Let's do it version 2. Okay, it should work. All right. So what happened? I'm not very sure what was the error raised. What I just what I just did was that I just configured a chip to use my past project because I already deploy the same model with a version 1. So here I need to rename it as version 2. However, I believe that when you run deploy your model like freshly, this command should run successfully for you. Okay. Any questions, guys? Wait. Okay, it takes a bit to deploy it. Okay, that's fine. Now let's go. While we're waiting for that, let's go to the custom prediction routines. So now let's say, as I explained that sometimes, well, let's say your model requires the image of size 224 by 224, right? But the image that you receive from the client is like in another size, so you need to resize it to like the preferred size one. So what you can do is that you need to do is you need to write the custom prediction routines. So what you need is that, okay, you need to load a zip package of these files into the GCS. Exactly is that, let's say here I have my model, right? So under this, okay, let's say here where sorry. So here under folder scene, right, where I save all my train models, right? I need to load that custom prediction routines package, the zip file, right onto this directory. Okay, so in this zip file, what you need is two files, preprocess.py and predictor.py. Okay. So within the preprocess.py, right? you need to write a class. Here's a class in Python. The instruction, the instructor, the constructor for the preprocessor class is gonna be none. However, that class doesn't have a function called preprocess. It should be. So within the preprocess function, right? So let's say here, I say that I need to resize or images into the size 224 by 224, right? So here I use this function to resize the images, and then I will standardize the image. Standardize here is just like a step in the image reprocessing. You can ignore this step. That's fine. Even if you want, well, that's totally fine. Well, what I try emphasize is that here, these two are just two functions, two lines for image reprocessing. So after you're done with defining the preprocessor class, then you need to write, okay. Oh yeah, wait. So before you can, well, before you go, you go to the create.py, you need to do a step called that you need to serialize the preprocess. Okay, I don't know why we need to do this because I mean, to be honest, I don't know like how GCP is configured that way because in AWS they don't need to do this. Okay, anyway, but so here you're gonna initialize an object of the preprocessor class, right? And then you will need to serialize that preprocessor class into the PKL, which is the picker file. So this picker file again will be loaded into the GS under the same directory as the model folder. So now you need to write the predictor class. So within this predictor class, you need at least, I would say, 3 functions. The first one is the constructors. So in the constructor, you need 2 arguments, model and preprocess. So the model here is okay. So in this construction, right, it requires the model in preprocess. So okay. So the model in preprocessor here, these 2 arguments will be provided by this function class, by this class method from path. So simply that GCP, when you load this predictor.py file into the GCS, right, and when you deploy it, the GCP will use this function from path here to load 2 things. The first one is the trend models. So here's GCP will use this function cf.keras.models.load models given the path. So here, this function will help you to load the trend models. Okay, and then the GCP will load the preprocess. So given the trend model and preprocess loading, it will return the pair of model and preprocess, and the output of the function from path will be fed into the constructor of the class predictor. So now the class has the model and the preprocess. Now it's ready for predict. So in the predict function, right, you need to prepare input. So here, I assume that half the input is the image, right? And I decode into the byte and save into input variable. So the preprocess step is that I basically just pass the image input into the preprocessor and get the preprocess inputs right here, and then I make the prediction request and return the prediction right here. So these are for the custom prediction routines. Okay, so after you defining predictor class and you defining the preprocessor class, now it's a job to load them. Well, you need to load the model to I'm sorry, you need to load the preprocessor and predictor in a zip file into the GCS. to do it quickly, so here I have a sample of the setup.py file. So whenever you execute that setup.py file, it will zip your two classes, predictor and reprocessor, into this zip file, right, and load it to, and then after you zip the these two classes, you can copy, or load it to the into GCS. Okay, so okay, so right here, when you execute the setup.py file, you will have a zip file called custom.code and tar.gz, right? So here you need to copy and or load that zip file into the folder underneath the folder where your train model is located. And then similarly, you need to load the serialized precursor into the same place as well. All right. So that is how you configure the custom prediction routines. Okay, right here. All right, looks like our model is deployed successfully. So after you create the versions, right, you should have no errors. So no errors mean that, well, you just successfully deploy your model. Okay, great. Now let's go to predictions. So in AI platform, they support both batch or online predictions. Online prediction doesn't mean that for every single request you will make the predictions for that request. For batch, doesn't mean your model or AI platform will predict multiple. The AI platform will serve multiple prediction requests at a time. Okay, so in order to send your the data, let's say the prediction request to the AI platform, right? You need to configure your data. So similar to the standard REST API, you need to send the JSON object to the AI platform. So here I have three examples for how to configure JSON objects for different data type. I have tabular. So for tabular, they are just simply the 2D array. So here I got a 2D array, right? And which is this 2D array is the value of the key instances. For text data, simply you have the text hello world and you wrap it with the list, and that list of text will be served as a value for this key. However, for some special data such as like bytes data or binary data such as images or like music file, you need to decode it. You need to encode into the base64 encoding string format. Okay, so you can, it depends on your project. You can either send the text input to the AI platform for predictions or tabular or image. Okay. All right. So that's for some examples. Now let's, as I said that here, we need the JSON object, right? So here we need to prepare the input for the predictions. So here I simply I load some sample images from the MS dataset that I mentioned earlier. So in the dataset I have these 5 classes, right? So here I would take one sample from the class sunflowers right here. And okay, wait. Okay, because the function happened. Give me a sec. Okay, now should work. So here, I'm gonna take one sample from the class sunflowers. And here now I will use a package called CV2, which is the path version of OpenCV. I will read it up using cv.toImage read to read the images, right? So so clearly here you see that the image here, it has a size over to, I think about 250 by 320. So the size is not preferred by our model, so I need to resize it. Okay, so here I resize it before I send, because here I resize my image before I send to the GCP, because as I mentioned, the custom prediction routines in GCP, they in the beta mode, and there's of constraints. I did try to do it, but it I would say the custom prediction routines mostly it work well with table data, however, or string data. However, for image data, it doesn't work that great. So that's why I resize my image before I send the image to the GCP AI platform. So here I'm using the function resize of the OpenCV to resize to the size 224 by 224, which is preferred by the model. Okay. Now, here, because we need the input, right, in the file JSON format to send through the API rate. So here, because I use a function toList, because before that, the image here, it is the type of this input is, well, the type of the input is the NP array, numpy array, which is not the Python to the array type. So I will use toList function to convert from numpy array to the Python array, and then I serialize that that to the array into just an object. Okay. Oops, sorry. I don't have the import JSON. Forget it. So if you check your files here, you should have a file called prediction underscore input JSON. Okay. Next is that now, given that JSON input file, now you will use the gcloud command to make predictions. So here, gcloud AI platform, very similar to a gcloud AI platform like training or whatever. Instead of training, here we use a function when you pass in the word predict here. And okay, and here the predict function, it requires the name of the model, which is CNN, the version. So because I changed the version to version 2, so I need to change to number 2 here. For the region, it will be the US Central one. For which region to use, it's totally up to you, but usually I use a US Central one. And then here, for the argument JSON instances, you need to pass the path to the input JSON for object. All right, so the predictions is the array of 5 numbers, because what? As I show here, in this data set, right, it has 1, 2, 3, 4, 5 classes, right? So the prediction will be 5 numbers, that each number, a float number, correspond to 1 class at a time. Okay. One last thing. So that's the very much how you deploy and make predictions on the machine platform. How you deploy the machine models on GCP, and how to make predictions right on GCP. So here I show you using the gcloud command. However, you can still using Google Client API or REST API to view it. Well, okay. Well, so this my tip, actually my recommendation is that I did try Google Client API, and both REST API somehow it doesn't work well. Maybe I'm not that good with GCP, but I think rather than just like if you can like figure out how to do it, that's great. However, like I think for the hackathon, right, let's do a quick fix is that you can basically using the subprocess package. I mean this package subprocess. So subprocess package in Python is a package that will help you to execute the command lines, right? So when you use subprocess, you can execute this command here, like right in the Python code, and capture the output, which is here you will capture the output from the model here. So I think the output for the model will be internal string. So perhaps that you need to like you need to like remove the square brackets here and remove the comma, remove the space here to get only 5 numbers, and that is how you well that's like how you use a subprocess package um, to execute this command to make predictions. Okay. Any questions? Okay, so so here instead of image right, you can simply using okay, for example, wait, where is it? So here instead of so here I have the input is the 2D array of which is the image right. Instead of that one, you can replace this image with a string, right? And just serialize the string into the JSON object. You can do the same thing with tabular data as well, and just simply send it using the gcloud command to make predictions. Okay. Any question, guys? No. Huh. Section. Okay. No. All right. If you don't have any question, I will. Still, you can look at this notebook in order to like go over step by step how to deploy the machine models and make predictions on using a GCP. I will copy and drop this link into the into Hack AI channel so you can look at that later on. Okay. If nothing, okay, I will stop the session now. And thank you for coming to the workshop.